Hello everyone, it's June 13th. A little bit later than I wanted to start, but it's fine. It's a Sunday, so I'm expecting another difficult one. We didn't do very well yesterday. Um, it's always about DP, right? I mean, all the difficult questions that we have trouble with mostly is with DP. And I mean, I always think I have a good grasp of DP, but sometimes just the what the DP should be, right? What the DP should be. And sometimes it's not as obvious as just just look at the question like, oh, yeah, I'm going to DP on whatever is on the surface. But sometimes you have to think a level deeper. Like yesterday, the DP is a level deeper. I wasn't able to get it. Felt a bit bad. I thought that one I shall be able to, at least the OM square solution I shall be able to figure out. Anyway, let's take a look at today. I'm prepared. And let's take a look. Palindrome pairs. Okay. Given a list of unique words, return all the pairs of distinct indices in the given list so that the concatenation of two words is a palindrome. Ooh, 0, 1 is a palindrome. 1, 0 is palindrome. 0, 1, 2, 3. 3, 2 is a palindrome. But 2, 3 is not a palindrome. And 2, 4, 0, 1, 2, and 4 is a palindrome. All right. All right, it's an interesting question. I mean, apparently we have 5,000, so O(n) squared can get all pairs, but I'm pretty sure it's going to time out if we go O(n) squared. O(n) squared just everyone pair with everybody else, and not only just pair, we also do the reverse pair. And 5,000 times 5,000, we're talking about 25 million times. And plus the palindrome. Ooh, it's likely, we know this will work, but definitely it gotta be a better way. Okay, let's think about it. A better way to do palindrome without direct checking each pair. Pair, so we want pair of 2. How do we get a pair of 2 without going through all type of pairs? I mean, we say each word is unique, right? Each word is unique. We're gonna say like, so for A, B, C, D, right? What to say, instead of checking which one is palindrome, and say what can we make A, B, C, D palindrome? Well, A, B, C, D, it's to make a palindrome. It has to be, well, DCBA, that's one way. You just have to analyze what are the other possibilities. Yeah, if we can find, so the question is for each word, which is 300 letters long, we need to find all possible palindromes, going to front and going to back, and I'm going to look into it to see if we can find it. That is the question, right? It's kind of a reverse, so we don't have to search each single one, we just see what we can get. I mean, the most is the repeat of the entire thing, so most is 300 long, right? And then, like for ABCD, we know DCBA will work, so just reverse this will definitely work. We can look for it, see if there is any one that is the reverse. And then we have the analysis part, right? How do we analyze a string to find its possible pattern? Like for this one, right? We can say, put at the end, we can say SLL, right? And on the front, we can say SLL. Right? SLL is palindrome. S is palindrome. SL is palindrome. Right? We have multiple choices. How do we handle it? So we just say, if we say easiest case is that we take the entire thing, we flip it, right? And then we say we want one of them to be in the center, like to be part of the palindrome, and then we say it be LL, and then we say I want these to be, and then oops, we cannot, so that's it. So we go from the other side. Again, we have LLS, so we have SLL, right? And then we want 1 to be, and that will be SL. Now we want 2 to be, that will be S. We want 3 to be, and that's a no-go. So for each one, the maximum is 300 on one side, right? 300, like we go each one of them, like we go 300 times on one side, and we go 300 times on the other side. All right, so how about if we have like AAA? Well, how are we gonna handle that? If it's AAA, we go both sides, then then it is so different. It will produce different results because the order is different. Let's give it a shot. Like just kind of get an idea, right? So if we say AAA, A, right? Like this. Very weird test case. It should be a combination of all pairs, 0, 2, 2, 0, 1, 0. Yeah, that makes sense. All right, let's try this. So we need to create a dictionary? Yeah. We need to create a dictionary that has the mapping of the word to its indices, right? So that's the mapping we need to handle. All right. Copy on this. All right. So to do palindrome pairs, we're gonna say index map equals this, right? W for IW for no. W I for IW in enumerate words. So this is to create indices, right? And then result is going to be this, and then we say for what? For IW in enumerate words, and then I'm going to say produce palindrome. Now we need to produce palindrome, so I'm going to say on the right, on the left. It should be the same, right? On the right is just this on the right. On the left, let's see. We can say a number of for J in range, so 0 overlap J is number of letters in the word W that can be shared in the palindrome. Right? That's part of the palindrome. So for J in range 0 to maximum is going to be len W plus 1, so 0 to that number, right? So if a 0 number, we can go left or right. So if we go right, then we say one's inside has to be palindrome. So we do need to check. So we say if J is 0, it'd be 0. All right, let's put I want n. N equals len W. So I'm gonna swap it out. N, right? So if it's gonna be W, we say n minus j to the n, right? N minus j. So if we say 1, a 0, that will be n to the n. That's nothing. And if n is 1, then it's n minus j minus 1 to the n. If this one is equal to minus j reversed, right? If these two are the same, right? If these two are the same, then we say then we say the palindrome is equal to what? To W from the start until n minus j, right? N minus j, and reversed, right? There's a check. Yeah, let's do it like this. This is a check palindrome on the right side, right? So I'm gonna do this. J to this, and then palindrome to this, and then we say if palindrome in index map, then res.append I, right? I and index map pal, right? And then else, once it cannot match, then we just break. So that's check on the left. So we can do exact same thing, but they check on the right, check on the left, right? We can do check on the left side, right? So the left side will be slightly different. The left side will be from 0 to n minus j, right? N minus j, not n minus j, to j, right? To j. If this one equal to this, then, well, actually I'm not sure, so I'm gonna test it to see if 0 works. So let's say, it doesn't matter, A, B, C, D, right? Let's say A 0 equal to A 0, and we're gonna reverse it. Yeah, it gives it true. So if this is true, then palindrome is going to be, we hit J, so it's going to be from J to the end, right? J to the end, and then reverse it. And again, if palindrome is in, then we add it. No, we have to add it the other way. So the palindrome shall go first, and I is going to be here, right? So again, if we find one that is not, then we don't need to keep going. So we do this. After that, we are done. Return the rest. All right. The test case, we have to order it before we do test case. So A, B, C, D, right? DCBA. This is LLS, S, SSSLL, right? And this one we will get 0, 1, right? 1, 0, 2, 4. Let's order it. Oh, actually, it doesn't matter. We can just use it. We can order before we make the test. And the last one is 2, 4. Okay, so that's the first test case. Second test case is bat, tab, cat. Give us 0, 1, and 1, 0. Next one is an edge case. Oh, edge case. Interesting. 0, 1. Let me check if the edge case work. 1, 0, and we have one more case. I'll write it here. Right. This test case, return the result. This, of course, we have to handle the quotation marks and all these, right? And then change it. This is going to be words, and this is going to be palindrome pairs. Words, and we're going to say sorted, right? Equals sorted, then pass. That is not correct. Oh, we have repeats. We have lots of repeats, I think. Hold up. We get Oh, why would we get repeat? Ah, we do get repeats because I check, I put it in, and now I do it again. Ooh, we have to do it as a set, right? We do it as a set. Oh, let's see if we can avoid repeats as we're doing it. I mean, I'm looking at myself and I add something to the right, right? And then, yeah, I can like set up another data structure to record whether something has been found, has been already incorporated. Like if A add B to the right, then for B can add A to the left, right? So we don't have to consider that again. I mean, there are two ways. One is we just turn result as a set, and we're gonna pass, we're gonna just say add a tuple, right? And at the end, we turn everything into lists. That's one way to go. But there is also another way, which I think is more elegant. So we can say someone has been added to the right, right? When you say to the right or to the left. So if someone has been added to the right, then we do not, when we enter this, we do not look for, because everything is unique, right? So that can only happen once. Therefore, I think that one should be a better deal. So we're going to say already added, right? Added is going to be left, going to be a set, and right, going to be a set, right? So this basically just saying is added. Okay, let's make it more explicit. It's like it's me. I'm adding someone to my left. So it's two left. Yeah, it's like this value is it's been added to someone's left. This is added to someone's right. So when I check it, right, the number, the word, if it has been added to somebody's, this will add to the right, right? Or check palindrome for something to add to my right. So I check if I have been added to somebody's left. If I have, then I don't do it. Okay? So I'm going to do this, right? So I'm going to say if W not in added left. So if I have not been added, the current value I have been not added to someone. Actually, hold on, I am trying to see someone can add to my right, right? So if I have not been added to somebody's left, yes. If I have not been added to somebody's left, then I can do this, right? We find it. Once we find it, like I have not been added to somebody's left. Now once we do this, then we can say added left dot add W. So I have been added to somebody's left and added right dot add palindrome, right? So palindrome has been added to somebody's right. So the same thing happened here. We say if W not in added right, if I have not been added to somebody's right, then I do all these maneuver, and once I find someone, I say added left or right, right, dot add W. So I have been added to somebody's right and added left dot add pal. So the palindrome has been added to somebody's left. So with this, I am passing one, but I am failing the others. Let's see. I have a 3-3. Oh, itself. But failing on itself. Okay, so if palindrome in this, if palindrome has to be not equal to myself, and yep, this is the condition that we need to follow. Which one? If palindrome here. If this and okay, we passed the majority and we fail on the last one. So why do we fail on the last one? This is 0, 1, 0, 2. 1, 0, 2, 0. I'm missing 1, 2, and 2, 1. I think this is telling me that it's not working. So I only add, so if I remove these, so this is just like I'm not considering those again. Hold on. So 0, 1, I say 1 has been added to somebody's right, but 1 can be added to another person's right. 1 can be added to 0's right, 1 can also be, this is not gonna work. Even if I remove these, I think it's still gonna fail. Yeah. Nope, 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 I don't want this. Let's do it the other way. Let's do it a set way. The least amount of trouble. So basically, we're just gonna call it, I mean, how long? 5,000. What length is 5,000? Nah, let's just do it easier. So this rest, let's say add, and this is gonna be tuple, right? We'll just turn everything into a tuple. And no, none of these extra checks, because it's not really necessary. So no this check, put in here, and then say where? Here, add, and then we'll remove this. Yeah, that's wrong. So return this for then list R for R in rest. Now we pass everything. Alright, hopefully that is not going to be too troublesome. Alright, let's run it. Pending, judging. Oh, we got a wrong answer. I was very confident, but we got a wrong answer. Alright, gotta figure out what type of wrong answer it is. I don't know. I mean, what could be the wrong answer? We got correct on this one. This is what I think is a tricky one. Let's see. All the pairs are distinct with a palindrome. I have a few. Yeah, let me try. Let me see. I have a few things that I can try. For example, this is basically weird test cases, right? So we say, I don't know, AA, and we give it an empty. Then we give an A. So we insert an empty and see if we get. I think this is correct, right? Yeah, I'm not sure. So run it. A, empty. Give us this. Of course, we need to handle all the comma. Yeah, that's correct. So that's not the case. So what about BBB? And B, like we have two. We have two cases here. Yeah, that's actually not. I don't know, I'm just throwing things at the wall, trying to see if anything gets stuck. Ooh, I also handled this one correctly. What was the wrong answer? Well, think about it again, right? So for each word, I get its all possible palindromes from it, right? All possible palindromes from it, including the entirety. And then I look for the index, right? And I put them together. And I also considered the situation where we have, right, put it on the right side, so we go 0, 1, 2, 3, 4, until we hit a moment when this is not palindrome. Hold on. I think I know. I say 1 is palindrome, 2 is palindrome, right? Say if 2 is palindrome, but 3 doesn't have to be palindrome. Yeah, this is considering that the center is a palindrome. Yeah, this is not right. I'm considering the center is a palindrome. I'm considering like say this is a palindrome, so I add, right? Or this is a palindrome, so I add only this, right? That's one way. But it doesn't have to be palindrome. It does not have to be palindrome, right? I mean, it could be, hold on. Palindrome. Like, we do SLL, right? And then we say if we include S in the center, so we do LL, or we do SL in the center. If SL is not a palindrome, then we have to do SL, which considered when we do SLL. That seems to be right. And there's one way for us to search for a correct answer. We can just write a generic one and we use a random string. Let's do that. Let's do that. I have Ghana today, so let's try that. So we're gonna go solution 0. We're just kind of trying to see, right? So this one will be very, very generic. So say result and go to this, right? Let's say for I in range len words -1, right? And then we say for j in range I +1 to len words, right? And then just say if so combine concat equals words I plus words j, right? And if concat equals concat -1, then we say rest out of hand ij, and if concat is going to be j and I, then we say it's going to be j and I, right? And then when we're done, turn rest, right? We can actually check on solution 0, which I'll pass as well. Now is going to be the interesting part. So we're going to comment out this, right? What I'm going to do is solution base, for the baseline solution, and it'll be solution 0. and solution is going to be solution, current solution, and test case. Test is going to be equal to, so I'm going to randomly generate. So how do we randomly generate? So it's going to be, we have to say from random import rand int, right? So tests is going to be this for this in range len w for this in range len for range and let's say just gonna rand int the word length is 300. Let's say word length max word length equals, let's say just 10, 5, right? Max words, and then not max words, n equals word length max n equals, that could also be a random. So we just say max n is, let's say 5, right? We'll do 5 and 5, and then in range rand int from 0, right, to max n plus 1. I think it doesn't include the last one. So this is going to be range, how many times? Word length 1 to max word length plus 1, right? And then this thing, we're going to say this dot join this, right? And then this is going to be char 97 plus rand int from 0 to, including both ends, 0 to what, 26? I think it's 26. No, it's actually 25. I think it's 25. That's 26 characters. So it's not going to be plus 1 because we're including the end as well. So it's going to be this. So that's the test case. And then I'm going to say for I words in tests, enumerate tests, right? I'm going to say answer equals sol base. Let's call it sol 0. Solution 0 dot what? Dot, what's the name? Palindrome. Palindrome pairs words, right? So that's the answer. Result going to be sol dot palindrome words. Actually, let me say sorted this and sorted this. Right, so both are sorted. We say if answer is not equal to res, right? Then we if it's equal, then we say print test I pass. Otherwise, else, I'll do this. I'll print out the entire thing. Test this fail, answer, result, test gonna be, we can actually say test equal. I can say result equal, so I don't have to make it simpler, equal. Right? And then that's it. All right, run it. or you have lots of issues. Expect list found. Okay, so I think this is not going to be this. For list in range, do much this. Probably here. Let's get too complicated. So this in range, one of them is not matched. Unexpected parameter equal. Oh no, that's just because this thing is not right. Alright, so this is this parenthesis range, right? And then we do this char. Oh, I think we forgot this. Finished in this. A named, undefined name test. Oh, there's no test. Oh, words. Oh, we have fail. Wait. What's a test? I feel like the test is not right. Tests is no. This tests. Oh, that's just a single one. This is and I have to do a number of, so I have to one more layer for this in range num test. So I need to do one more layer, say num test. Let's say we're gonna do 5 tests. Right? Go. Oh, I'll pass. Alright, so this is not enough, so we're gonna have to get a longer number of tests, let's say to 100 tests. Oh, we have a fail. Right here. Answer is gonna be 0. Oh, unique. Has to be unique. Okay, so that means this is going to be a list of set. We can delete this one. We can delete this one. Set list. Okay. Try it again. Make the words. All right. So let's get max n. That's the length. I don't want to change the length, but I think I can change this. For the longer words. I don't see any, huh? Alright, so once it pass, we don't do anything. Just nope, let's do more. Oh, here we go. Answer is 0 and 1. But result is wrong. Okay, let's see. What is the case? I still have G, right? So we're looking at G, and J is going to be 0 to 1. So we say 0, and we need to find somebody who is G. We don't find any. And we do 1 is G by itself. It's good. So we need to find an empty. There's no empty, so this one's gone. And on the left side is the same, so this one is no-go. So here I shall be able to add, because this is good. There's something wrong with here, right? So, because we need to add it to the left, so G, we want the fancy, maybe this one can pass. Not sure. I think this one will time out, honestly, come on. But just for fun, right? Just for fun. I feel like this one's gonna time out. But technically, this one is correct. Yeah, let's just run it and keep understanding this one. So we have J, right? J from 0, which is 0 matching. Oh, 0 matching, I already say else break. That's the problem. We should not break it. Like 0, I say I check the entire thing, and it's not matching any. So basically, we want to find if any of these is palindrome. Oh, I didn't know you can do that. Huh. I just want to know any of these things is a palindrome, right? So I think what we can do, instead of going this way, right, we can just go 1, 2, 3, and just check if it's palindrome. Which actually exactly, we check 1 is palindrome, and 2 of them, 3 of them, right? Once they are, it'll be added. But once they are not, we should not break. I think that is the gist. We should not break. And we're going to test this one here, right? By just, so when we test this, we comment out this, and we add this as our test case. Oh, come on, I cannot copy and paste? That is stupid. I don't know, it didn't come out. Oh yes, I can. I think it's just that it's not showing. Alright, so that's a test case. So we can do here. Test case, this one will give us 0 and 1. Alright, so I'm gonna run it and we pass it. Okay, so yeah, we have to go through all of them. You think this one pass? No. Time limit. Yeah, it's as expected. As expected. All right, try this one. Pending, judging, pass. Yes, that is the problem. That is the problem. So we shouldn't, right? We shouldn't. So you see, this is like, you know, some test cases wrong, and you're pretty sure the logic is right, and you have a backup. I have a backup plan. So you just run these little technique to try to find the wrong test case yourself. Okay, so where do we put it? We just say, actually, if you look at this, I think we can find a way to write these together, right? Instead of putting them separately. If this equals this, I mean, for sure, what we can do is, when I save one line, that's for sure, we can put these two together, right? You don't have to run 2 for loops, just 1 for loop is sufficient. Plus this one, I want to write it here. And then I'm going to say check pal, paling, check pal on the right side, on the left side. So we don't have to do this one anymore. Right? So we say, instead of the naive, this is naive solution, naive ON squared, right? This is naive ON squared solution, TLE, and this is instead of the naive ON squared, we can analyze each word and see what other word is needed in order to form a palindrome with the current word. The check needs to be on both sides of the current word, right? The current word, on both as a current word. We check. Say, let's say we are checking to add a word to the right of the current word. We say we say 0 letter from the current word, from the right side of the current word is shared in the new palindrome. Then the other word must be word reverse. We then say one letter from the right side of the current word is shared, then the other word must be word n minus 1, right? N minus 1, and then do this. We can then say two letters from the right side of the current word, suit of the current word is shared, then these two letters must themselves also be palindrome. Then the other word must be word n minus 2, right? And then minus 1, etc. We record any pairs that satisfy the requirement above for both on the right and left side to avoid duplicates. To avoid duplicates, we record the result in a set before finally returning the list version. So the runtime is going to be on, because we have to go through every single word, right? And one more thing, we must build a word to index mapping to know which index each palindrome pair corresponds to. Right, so on is to, we build this as on, then we go through the on, and with each one we have to go through. So on times m, right? Where actually I think it's no, I'm gonna use, so total is gonna be, let's say k, where k is the total number of letters, right? Total number of letters in the words list, right? Total number of letters in the words list, which amounts to 300 times 5,000. So that's faster, yeah. Okay, let's take a look. The runtime, 596, I think that's the one, milliseconds, or we say 59% ranking, if I remember correctly. Yeah, 59%. 596 milliseconds with 59.62%. So I think that is probably the solution. All right, this is not a difficult one. This is a medium. Must be a medium solution, a medium question. So we got an easy one today. I was preparing for a battle, but we're handed a easier battle. Not complaining. Oh, it's labeled as hard. Huh. What? See, this is like what I say, hit and miss, right? Okay, I think I've done this before then, because this idea came very organically to me. I feel I've done this before. No? Wow, I am very wrong today on many occasions. So it's a cause for celebration. I think we did it very well. It's a difficult question. I have not done it before, but very organically, I came up with a solution of the think in reverse, right? Think in reverse. All right, I'm not complaining. I feel happy. That's kind of ooh, a trie structure. Wait, they say O and K squared. Why would it be K squared? Are they counting on this? You know what? That is correct. Yeah, I need to rewrite. It is K squared because all these reverse, right? For each one, that's all. That's let's say K is the average length of the word. That's OK, right? And within this, no data. Oh, it's reconnected. Oh, okay. Wow, no data over there. All right, so I just want to use try. Oh my god, it's a lot of words. Oh, oh my god. Oh, it's long. Oh, it's long. Second coding question. Yeah, of course, you're not happy. I mean, we didn't solve it in half an hour. We solved it longer than half an hour. Post string A plus prefix string. I mean, now I feel like my solution is much better than this, right? Like the palindrome is using a try. Then you have to build a try. Every time you build a try, I just feel like I don't want to build a try. So what is this? Is the letter in parentheses indicates the value of its word. False, 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 true. Yeah. So I don't understand. So word BA, starting from the first character B, indexing to the root. The starting node is no, and we know there are no words ending on this character, so the searching process is terminated. For word A, again indexing to A, for yield node N1 is not null, then we check the value of N1's word. If true, it's possible to obtain by appending this word to the one currently being examined. Wait, mine is it's the same, right? It's the same, but without the try, right? Without the try. I mean, honestly, I don't want to read this. This is just look at the data structure. It's so complicated. All right, does anyone else solve it using my easy to understand Java solution? 2 is reversing string, then is a palindrome. Palindrome then exists. S2 is a reverse of, then there's a palindrome, similar to case 3. If S1 cut plus 1 to the end is a palindrome, then there exists. Yes, this is the one. This is the one. This is the one that that I am using. Oh, why is this so long? They do a hash map, exactly. Special case, I don't have to consider special case. All string, that's the reverse string. On the first pair, I think these can be combined. Yeah, I think these can be combined. I wonder how do I come up with this? And like I said, it's this question is old. Like this one's written, last added in 2018. So these are old questions. I mean, back then. I mean, like I said, all LeetCode questions, the difficulty has inflation, right? Has inflation. Like the difficult questions in the past, and apparently this is a very early on question, right? Difficult questions in the past no longer feels difficult now because more people are practicing. I have been practicing, so a lot of things become less difficult. 45 lines. My God. Is this what Java is? How many lines do I have? I have 13 lines. Which, if I want to, I think I can even shrink it. I could cut a couple more lines. I don't have to do this. I can cut one more line. Right? And yeah, I think probably one more line that I can cut. I mean, looking at this, I never want to write Java again. This is ridiculous. Convoluted. I think it's because they're checking. Oh, they're checking on to avoid duplicates. So they're avoiding duplicates, but I say I don't care. I'm gonna remove the duplicates by adding as a set. I mean, it doesn't really hurt the runtime. The runtime is the same. And make your code easy to read. Okay. Yeah, it's the same. The append. If j is not n is parent, j is not equal to n. Back. Dot append. How do you handle the the average word length is not long. Average word length is only 300. Yeah, they did not check. They did not check for. How do they avoid? I mean, there is something I don't know. I do not know. Prefix, suffix. Ah, okay. Prefix, suffix. Ah, yeah. Prefix to j, suffix j to the end. And then if back is not word and backing words, what is here? Then we append. How is this possible? Right? How is this possible that they don't encounter any duplicates? I have duplicates. They just append it. Hold a sec. Hold a sec. Let me try. Come on. This doesn't feel right, right? Does not feel right at all. Let me try here. Let me try to do this one. Solution 0. Oh, actually, I didn't test the actual solution. Oh my god. It shouldn't be solution 0. Yeah, it passed. Of course, solution passed as well. But how? How did you pass? Without checking for, like, if I not do this, then I'll have duplicates. How do you avoid duplicates? If pre equals to pre-reverse, that's checking this, which is a palindrome, right? If it's palindrome and pre-post is not equal to W, oh, I think this is the check. This is the check. I don't think they're checking here. Suspicious. Suspicious. Oh, wrong. Oh, solution 0. Indent error. Of course we have indent error. Dict object has no attribute item iter items. Not iter items, with items. Hey, they pass! Wait, what the hell? Prefix for word, I have prefix and I have suffix, right? So if the prefix is palindrome, and back is suffix reverse. Prefix and back is suffix reverse. And if back is not equal to word, and back in word, so we put this in K. Okay, that's good. And if J is not equal to N, I think that is to, if J is equal to N, and that will be the same as a prefix will be equal to the word, suffix will be empty. So that is a situation we already considered when J is 0, right? And say it's palindrome suffix. Then back equals prefix reverse, and then we enter the back. But when we hit the back, when we hit the back, because the back is in words, right? So when we hit the words, when we hit the back word, and then we do its prefix and its suffix, and okay, from 0, so the prefix will be 0, suffix will be the whole word. Prefix is 0, and suffix reverse. Isn't this already considered in the past? I don't understand. Like, I tried, right? How is this not resulting in duplication? Prefix, like if we have a right, and we check for everything that's fitting this one, right? So if I have 0 and if I have 0, 1, we've already done 0, 1. Oh yeah, but we didn't do 1, 0 because we're checking on the current word. So we do this one. Say we have 0, 1. Let's say 0, 1 and 2, 0. That's for current 0. Now we're hitting 1. Right? We're hitting 1. Then 1 must be 1 something, something 1. That is not repeating. Right? If I have 0, we put 2 on this side. If 1, we put 2 on this side. So even if we have 0, 1, we will not encounter 0, 1 again when we are at 1. No, we will. We have 0, 1 put in, so 1, we can look for 0. then it repeats. How is this one avoiding repeats? Huh. Hold on. So 0, and then we find out 1 can match, right, to the right. And then when we are at 1, then we find that 0 can match to the left. It's palindrome. Take 1 as its thing, and then so 0 can match to 1, create a palindrome. So 1 can match 0 on the left, right? I think the answer is no. If we have a string, and then we can find another string that can match to the right, right? And then we can create a palindrome. Now we're looking at this, the other string. Can we find? Actually, we cannot, because the base is different. The base is different. So each word is unique. So the base is different. The base is different. Yeah, that's correct. The base is different. So if I have a value at a 0 position, I can do 0, 1. That does not mean I can do, like I'm looking at base as 1, does not mean I can do 0, 1 again. Because the words are different. And in order to match, right, in order to match the base, right, we match it. But what if the two words are different? ABCD and DCBA. Right? ABCD, I say I can match DCBA. So with DCBA, I want to match the left. Why will we not match ABCD? Like if we have DCBA, right? DCBA, if I want to match on the right side. Hold on. So we have ABCD and DCBA, they match, right? So if I look at ABCD, I say I can match DCBA. If I look at DCBA and want to match on the left side, and we say we have to do ABCD, and we have ABCD, right? Then how? How is it possible? Oh, I think this is the key. J not equal to N. That means we are matching on a word. So it's like what? So word is the only possibility, right, for a repeated match. The only possibility for it, because each word is different, each word is unique. That means for anything, if we take a prefix, like it's not a full word prefix. So we take a prefix, or we take a suffix, and then we're doing this, the reverse thing, right? Then the generated palindrome will be different. Will all be different. That's why we don't have to worry. What we do have to worry is if the palindrome is generated by the full word, right? We do a full word reverse, right? So that's the one we need to check. So if we do a full word reverse, say on the left side, right? I've done it on the left side. Then what we say is, if I want to do it on the right side, we don't do the full word again. Right? That's what it's mean. Right? We do it on the left side already. Right? That's what it says. Right? We have a suffix. Suffix is allowed to be the full word. Right? And then we do suffix reverse. And then we put the reversed at the front. Right? So that's good. Right? That's good. And then we say j if it's not equal to, if j is equal to n, then we're repeating within the same word. There's a prefix, so we basically say prefix to the full word, right? The prefix, if j is n, then prefix is the full word. And suffix is nothing. But if we do this, then we will have the back is the prefix. The prefix to the full word, so the prefix, the full word reversed, right? The full word reversed. And we're saying we're going to pen K and words back. So basically we're saying if we have a word that we have both, we have its reverse, both on the, we can reverse, right? We reverse it, we put on the front. And we reverse it, we put on the back. Yes, that's the thing. Right? If we consider DCBA, we reverse it, ABCD, we can put on both sides. That's right, we can put on both sides. But now we say we are only allowed to put it on the left side. We do not allow to put on the right side, right? Therefore, this is going to be encountered when we have the next one coming in. So we always put on the left side. That is the trick. Nice, got it. Oh, this is this deserves to be a difficult one. The logic here is interesting, which means in my case, right, check on the right side, and then the check on the left side. So I said, okay, I'll put everything on the right side because j gonna starts with 0, right? So it's empty. And all the way, we say from empty all the way to the full length. And this is going to be the full length to start, all right? Because j is 0. J is 0. Hold on. This doesn't seem right. Check power on the left side. So 0, 1, 2. Yeah, that's fine. So 0. So I shouldn't check 0, right? If j is equal to 0, then that's the same case as this one. And we only want to do it once. So we say if j is not equal to 0, and we can do this. And we can just append. Just directly, right? And we can res dot append directly. Check palindrome on the left side, right? So we make sure every time we add, we always add on the right side. So we don't do it on the left side. And then we just can return res. Okay, So let's try it. Solution, right? Boom. There we go. That's the one. So update. Update from this solution, right? From this solution, I finally understand the trick of not including repeats. The trick is that when a full words reverse is needed to be placed, is needed. There was if a full words reverse exists in the words list, we only allow it to be placed to either left or right side of the original word. This guarantees that if one can be placed on either side of 0, then we only do 0, 1, and let 1, 0 happen when we are considering 1. I'm not sure if this even makes sense. If let's rewrite it. If word 0 is under consideration and words 1 equals to words 0 reversed, then this means, not guarantees, this means that if this happened, right, then we only allow 0, 1, but not 1, 0. This is, we will do 1, 0 when words 1 is being considered. This leads to the conditional check j not equal to 0. Yeah, conditional check. And we also do not need a set to prevent duplication. Very good. That's the thing, right? That's the thing. Just one line here, we save a lot of runtime. This might even be faster, I think. Right? If you try this, I think it'll be faster. Good solution. Yeah, I see. This deserves to be a difficult one. Yeah, I didn't come up with this. Yeah, I see it's faster. Without the need to use a set, the runtime improves to 544 milliseconds. Is it 77? 73%. Okay, that's a good one. And of course, you can write it better. Like the prefix and suffix way of describing it is definitely a good thing. Right? The prefix and suffix description, I like it. All right. That's it. That's about it for today. Good. I don't think any other solution will be the same. Yeah, we're not gonna do try. Come on. Who uses try for this? Too complicated. All right. I'll see you guys tomorrow. Adios.